Good morning. Today we are going to be reviewing for Unit 3 or Chapter 3, and this is going to be your homework assignment. Remember that you want to try to work it out by yourselves first and then come back to the website to see if you have any questions or if you worked it out correctly. Let's go and start with problem number 1. On problem number 1 it says, graph the linear system. Remember, we have a system consists of two different equations and identify the solution. So we're going to graph it, then we are going to identify the solution. The solution will be where the lines cross or intersect. First, to graph the first equation, it's already on slope-intercept form, so we can just go ahead and graph it. Or y-intercept is the -6. Remember, you need to make sure that you start on the y-axis. This is the y-intercept, so you start at 2, 4, 6. My slope is positive, so we're just going to go up 2 and to the right 3. Up 2 and to the right 3. And from there, we are going to make our line. Be sure to make the line all the way through and place arrows on both ends. The second equation is on standard form, and we are going to transfer to slope-intercept form in order to graph it. So we have 2x plus 3y is equal to -6. To place in slope-intercept form, we're going to solve for y. We're going to isolate the y. We're going to move the 2x to the right. That will become a negative. We have 2y is equal to -2x minus 6. Be sure to write down the x first and then the number. We need to isolate the y, so we're going to divide by 3, divide by 3, divide by 3. The 3's cancel, so we have y is equal to negative divided by positive is a negative, 2 over 3x. Negative divided by positive will be a negative. My y-intercept in this case is -2. So I'm going to start on my y-axis at -2. My slope is negative, so I'm going to go down 2 and to the module once again, down 2 to the right 3. If you notice, this is where both lines intersect, down 2 to the right 3. And I can also go the opposite, up into the left, up into the left. I'm going to go ahead and make my line. Make sure you make your line all the way through and place arrows on both ends. So the solution is at point 1, 2, 3, comma, down 1, 2, 3, 4, -4. Now, if you wanted to double check algebraically that this is the solution, we can just plug it into the x and the y of each equation, and it should give me a true value. But remember to identify your solution. On problem number 2, we have a word problem that deals with a system of equations. Remember that we are looking for two items. It says, a class of 132 students went on a field trip. They took 13 vehicles, some cars and buses. So there are two items that we're looking for, cars and buses. Find the number of cars and buses they took if each car holds 6 and each bus will hold 15. I'm off for my equation. Now, we usually deal with money, money, money. In this case, we're dealing with the number of students. We have 6 students in each car plus 15 students in each bus. And how many students do we have total? 13. That's 132. So this will give you the number of students that are in the cars. This will tell you the number of students that are in the bus. And this will be the total amount. Now, the second equation will deal with how many items we have. In this case, we have 13 vehicles. So there'll be the number of cars plus the number of buses will be equal to 13. Now from here, you can decide to solve it by substitution or combination. In this case, I'm going to solve it by combination, and I'm going to multiply it by -6. Well, I need to cancel the c's or the b's. I'm going to cancel the c's, and they need to have the same number and different signs. Therefore, I'm going to multiply this by -6. The top equation will remain the same, 6c plus 15b is equal to 132. The bottom equation will be multiplied by -6, so it'll be -6c minus 6b is equal to 6 times 10 is 60, 6 times 3 is 18, so it'll be -78. That will cancel. That will give me 9b is equal to 54. I divide by 9 on both sides, and that'll give me b is equal to 6. So I have a total of 6 buses. There's 13 vehicles, so that'll be how many cars? 7. Otherwise, if you're not sure how to get the letter C for the number of cars, you can just plug it into the second equation, and that'll give you 7 cars. But remember, just try to understand the problem, and if you know that you have 6 buses, there has to be a total of 7 cars. Let's continue with problem number 3. We need to be able to solve it by combination. Now remember, if you want to solve it by combination, we want to make sure that the equations are on standard form. That we have the x, the y, the equal sign, and then the number. On the second equation, we have the x, the y, the equal sign, and then the number. So that works well. They're already lined up, if you notice. I want to decide if I want to cancel the x's or the y's. In this case, I think it'll be easier to cancel the y's if we can just make this a multiply by 3 to make it a -9, and that will cancel with the 9y. So I'll multiply by 3. The top equation becomes 6x minus 9y. Don't forget to multiply the last number. Is equal to -24. The bottom equation will be 10x plus 9y is equal to 8. The bottom equation will remain the same. So the y's cancel. I have 16x is equal to -16. Be careful with your sign. Some of you guys are making little mistakes on the sign. Then I'm going to divide by 16 on both sides. The 16 cancels, so x is equal to -1. I found my x value. I need to find my y value. Remember your solutions where the lines cross. That's the x value. I need to find the y value, so it'll give me a point. To find the y value, you can decide to plug into the first one or the second one. It doesn't matter. You'll get the same answer. I usually try to plug into the one that has smaller numbers. So I'm going to find y. I have 2x minus 3 y is equal to -8. But instead of the x, I'm going to replace it with a -1. That gives me -2 minus 3y is equal to -8. Now I can solve for y. I'm going to move my 2 to the right, becomes a positive, or just add 2 on both sides. That gives me -3y is equal to -6. I'm going to divide by -3. Divide by -3. That cancels, so y is equal to negative and negative is a positive 2. My solution, or my intersection, it's -1 for the x, for the y is positive 2. Let's continue with problem number 4. On problem number 4, we need to be able to graph the following system of inequalities. So we have a system because we have 2 inequalities in this case. The first inequality, it's ready to graph because it's on slope-intercept form. So I can just go and graph it. My y-intercept is 4. Remember to start on your y-axis. My y-intercept is 4, positive 4. My slope is negative. So I'm going to go down 1 to the right 2, down 1 to the right 2, down 1 to the right 2, or the opposite. Up into the left, up into the left, up into the left. If I write the word slope, my line is going down, therefore my slope is negative. So it does match. I need to decide if this is going to be a solid line or a dashed line. This is less than, so it's going to be a dashed line. If it happens to be less than or equal to, that will make it a solid line. That means that the points that are on this line are not part of the solutions. And that's why we make a dash, to exclude those points that are on the line. I need to decide to shade the top or the bottom. This is the y is less than the line. So all the values that are less than are to the bottom. Remember, less than or greater than. If it's less than, you're going to shade the low side. If it's greater than, you're going to shade the top. And you can go and shade it, or you can just wait and see where the two arrows. I'm going to shade it for this example. A lot of the times I just want to graph both of them, and then I see where they intersect. But for now, let me go and shade it. For the second one, I need to, it's on standard form, I need to place it into slope-intercept form by isolating the y, solving for y. So I have negative 3x plus 4y is greater than 4. And I need to leave the y by itself. I'll move my 3x to the right. It's a negative, so it's going to become a positive. 4y is greater than 3x, positive 3x, plus 4. I need to leave the y by itself. I'm going to divide by 4, divide by 4, divide by 4. That cancels, so y is greater than 3 over 4x. 4 divided by 4 is positive 1. That is, in this case, is positive 1. Be careful with your signs. My slope is positive, so I'm going to go up 3, 1, 2, 3, and to the right 4. 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. And I can do the opposite. Down into the left, down into the left. This is also going to be a dashed line. If it was greater than or equal to, then that'll be a solid line. In this case, it's only greater than, so that'll be a dashed line. I need to decide if the solutions are the ones on the bottom or the ones on top. It says y is greater than, so that means the solutions are on top of the function. I'm going to shade that side. I'm going to take my D and shade it. And the intersection is what both shadings intersect. And if you guys notice, it's this triangle. And if you didn't shade it and just shade at the very end, you'll notice that both of them are pointing to this. And you can have two options. You can erase the other ones, or you can just make this corner a little bit darker, so I can see. You can highlight it if you want. Just with the highlighter, you can erase it, so just be careful. So those are the solutions for the system. That means that this point is a solution for both inequalities, or this point, or this point, or this point. Any of those points are solutions for both inequalities. Now remember that the lines are dashed, so any of those points that are on the line are not part of the solution.